Well, um, hello, my name is Daniel Oyoka, and I'll be taking you through the machine learning paper review. And the selected paper, the title to the selected paper is Fish Disease Detection Using Deep Learning and Machine Learning. And the keywords in this paper were fish disease, machine learning, CNN, which is the convolutional neural networks, segmentation, and ensemble module. Well, the computational problem addressed by the authors is that classification of the fish according to different classes, which are written down in the paper, which are the red spot disease, white spot, and the black spot disease, and the fresh fish, which are the making up four classes of different fish which were looked into this paper. And why is it a problem? Well, it's to identify relevant fish features which are to be used when classifying the fish, and when is this a problem? Basically, it's failure in differentiating between affected fish and fresh fish. And to who is it a problem? The developer of the module, and to what extent are they affected? Like, to give wrong predictions to them, like that. Basically, that's it. And for the modules developed in the paper were the support vector machine, which is a supervised machine learning module for classifying, and the other is a convolutional neural networks, which is a deep learning module for processing structured grid data such as the images. And the third one is random forest, which is just an ensemble module, like an ensemble module that is just that operates on construction of various multiple decision trees, especially during the training process. Well, the model evaluation approaches used in this paper were recall, which is just the measure of proportion of the actual positives, or the actual positive that the diseased fish that the module correctly identifies. And the other is precision, which is just the measure of proportion of correctly identified positive cases to the overall cases. And the F1 score is just it provides balancing, like it harmonizes the mean between the two metrics. That's the precision and the recall. And accuracy is just accuracy. It's just the measure of correctness of prediction uh, of the module by taking into consideration of both the true positives and the true negatives. And the strengths and weakness of the module used for support vector machines, the strength is it works well in high dimensional spaces. That's to say, in high dimensional spaces, which makes it effective for purposes uh, of tasks like image classification. And its weakness is that it's computationally expensive when it comes to training training the module, as it requires a higher data set. And the conventional neural networks, its strength is it's able to uh, to learn from relevant new features of raw data given to it, and be able to give exactly correct predictions. And the weakness to this is that it's normally considered as a black box, in cases that it's very hard to interpret how it came up with its prediction. So it's really hard to understand how it came up with like the process, how it is formulates, like how the model works to give results. And it's basically sensitive when it comes to certain aspects. And the other is random forest. Its strength is that it's robust to overfitting, as like for it takes in the average of multiple decision trees, like making it more efficient when it comes to predicting. And its weakness, it is that it requires hyperparameter tuning when it comes to the number of decision trees and their depths. for optimizing its performance. Well, the strength and the weakness of evaluation metrics used in the paper. For recall, its strength is that it's for higher recall, indicates that maybe like for higher recall, it's effective in capturing most of the infected fish that as like it gives exactly the number of fish that was infected. And its weakness, it comes at the expense of precision. And for precision, a higher precision, like a higher precision gives correct results, and its weakness, it works at an expense, it lowers the recall value. And the F1 score, it strengths that it gets rid of the trade-offs between the precision and recall metrics, and its weakness is only that it disregards true negatives while doing its computation when trying to evaluate the performance of a module. And for accuracy, it strengths that it provides simple intuitive measures of overall model performance, and its weakness that it misleads if the data set is imbalanced. That's to say, if you subject the model, like if a model is subjected with a number of of uh, of health fish when related to the number of infected fish that was subjected to it, it's most likely to give prediction uh telling that probably most fish is healthy. And yeah, the next slide is all about the reference to the paper, and there I pasted on the link. Thanks very much for following.